Hello, honors chemistry students. This is Mrs. Corman, and this is your first exposure to what I like to refer to as video lessons. Now, if you're in Mr. Stein's class, you're also going to be watching this video lesson. Mr. Stein and I are trying to give you an opportunity to kind of get a sneak preview of some expectations that you'll have next year when you are in AP Chemistry. We do a lot of video lectures so that you have the opportunity to watch and rewatch lessons, and that way you have more time in class to ask questions and work on problems. Sort of a flip of what you would normally do with being lectured at during the class period and then going home to work on problems by yourself. So this is going to be your first exposure to that type of lesson. Now this one's not the most exciting, it's also not very long, but it's really important to what we're going to be getting into in honors chemistry next, which is going to be some what we call energy profiles, little graphs that represent what's happening with the energy. And in order to do those, you need to understand a couple of things about energy. So that's what we're going to get into in this lesson. Now as we're doing this lesson, you do need to take notes, and you can put those into your notebook or on a piece of notebook paper, wherever you take your notes. As I'm lecturing, I won't really pause for you to write the notes. So if you want to pause the video as you get a new slide up so that you can jot down the information, and then you can just kind of listen to the lecture. And again, that's another benefit. Whereas in class, you might be having to listen and write at the same time. Here you can pause and rewind. So let's go ahead and start with first just a basic definition of energy. Energy is the ability, energy is something that has the ability to change its surroundings. And energy in and of itself, you can kind of think of it like information. You can store energy, and that energy can then be transferred to other things. Another analogy people often use in terms of energy is that it's like money. Okay, in the case that, well, I guess it's not money. We all wish it was money, right? Because we have lots of energy, not necessarily lots of money. But with energy, if you think of it like money, you could have your money. Sorry, my PowerPoint's going a little slow today. I'm not sure why. You can have money, but have it in a multitude of places and being used for different things at different times. So again, energy is this entity that can have various faces and uses, and you transfer it and you turn it into other things. We're going to get to a point in our notes, we're going to talk about law of conservation of energy, that we can't create or destroy this energy. All the energy that's there has always been there and always will be there. We're just moving it around into different places. Okay, so that's the basic idea that we need to be familiar with when we're talking about energy in this unit. All right, so let's start with macroscopic energy. The prefix macro meaning large or big scale, micro meaning small scale. So macroscopic energy are energies that are large enough to be seen. A very important one that we use a lot is kinetic energy. And you can see there on the slide that kinetic energy has the symbol of a capital E with a little k, the little k for kinetics. And we've talked about kinetic energy before. Kinetic energy is the energy based on a substance's mass and its speed. Okay, so it has to do with moving systems. We've also talked about gravitational potential energy. That would be Eg, so E and then the little g for gravitational energy. And this is the energy based on where the object is from the surface of the Earth. Okay, it's a stored type of energy. That's why it's a potential energy, and it's based on the height and the mass of the object. How much gravitational energy they have is based on that. So those are the first two types of macroscopic energy. We also have a third one that we haven't talked about. It's much more important and used a lot more in physics, and that's elastic energy. And elastic energy is a capital E with a little EL. All of these notes, for those of you taking physics next year or in the following years, these are going to help you with physics as well, because these terms are all used in physics class as well. So elastic energy is the stored energy. So again, it's a potential energy that comes from something being deformed and then returning back to its original position. So if you think of like a spring, if you compress a spring and let go, that's an example of elastic energy. So some examples you can put in your notes: a spring, a rubber band, a bent ruler. Imagine bending a ruler. Okay, that's all going to be elastic energy because of the fact that it's stored based on a deformed, what am I going to say? was going to say deformation. I think that's right. Deformity, let's use deformity. A deformity in the object and the fact that it wants to go back to its original position. Okay, those are macroscopic energies. We're not going to be spending too much time during this part of this unit worrying about macroscopic energies. More so, what's going to be important to us are the microscopic energies. And microscopic energies are energies that we can't see with, just our vision. We have to actually witness them through other types of interactions. So the first one that we're going to be using a lot is going to be thermal energy, which is ETH, little th for thermal, and it's really a branch of kinetic energy. It's similar to the kinetic energy, but on a microscopic scale, because it has to do with the actual motion of particles. So instead of the motion of something large scale, we're talking about something that we can't see, those particles. And that one, thermal energy, will depend on the mass and the speed, just like kinetic energy. It's going to be based on that. So thermal energy, very important one, similar to kinetic energy, so it will have to do with heat transfer, is what thermal energy is going to come down to. Our second type of energy that we have is interaction energy, and interaction energy will be symbolized with an EI, and that's the energy stored in a system due to the arrangement of the molecules. Okay, so again, this is a potential energy, and I think the easiest way to think about this is if you have particles that are close together, they'll have less interaction energy than particles that are farther apart. Okay, and again, it has to do with that stored energy. So closer particles, the ones that are closer together will have less energy, and the ones that are further apart will have more energy. Okay, think about like a solid, okay, versus a gas. If you have a solid, the particles are close together, they have less overall energy than the particles that are in gaseous form further apart. So the interaction energy is based on how they're interacting with each other, hence the word interaction energy. The third microscopic energy is chemical energy, okay, chemical potential energy. And this is the energy that has to do with the attractions between the molecules. So, for example, you have hydrogen bonded to oxygen to form H2O. So that is an actual chemical reaction, a chemical change. And whenever there's a chemical change, there's a certain amount of chemical potential energy. We are not going to cover this part in this part of what we're going to be discussing with energy. We're going to be focusing on ETH and EI. We're going to focus on the energy that has to do with the thermal change and the interaction change that's going to be occurring with our particles. Okay, and again, we're going to be turning these into graphs, but for this part of the notes, it's just about understanding the different symbols and what they mean. Okay. Now, a couple of other quick things. Energy transfer is going to be something else that's going to be really important to be able to discuss. And there's a lot of different types of ways that energy can transfer. One of the most important ones that we're going to discuss is going to be heat. Now, notice as you see heat's definition popping up here that it has a bunch of different symbols. A capital Q, a small q, or a delta H. We'll have a specific time that we'll use each one of those symbols, but the definition of heat is the energy transferred by the collisions of particles or molecules. Some people think that heat is hotness or coolness, and it really isn't. It's the energy transferred by collision of particles and molecules, which we ultimately do end up feeling as a change in temperature, but it can be other things as well. So it's important that you make sure that you're thinking about heat in terms of that definition. One more quick thing to put down on there is to remember that faster molecules, meaning the ones that have a higher temperature, will collide into slower particles, and the faster particle will slow down, and the slower one will speed up. So there is a transfer of energy that's going on there. Okay, and again, that's the same concept that if you put a hot pot of water right next to a cool glass of water, don't touch them together, but put them right next to each other, the particles will actually collide, and the cooler one will become warmer and the warmer one will become cooler. So the transfer of energy there from one thing to another is something that's going to be important in this unit. Also, something that's very important in this unit is law of conservation of energy. We've studied law of conservation of matter, but this is law of conservation of energy, which is essentially the same thing, just says that energy has to be conserved. You have to have transfer of energy. You cannot create or destroy energy. So the definition on the slide here says the sum of all energy in a system remains constant. It's just transferred from object to object or type to type. So again, same idea of law of conservation of matter. Now, one last thing, and then we'll be finished with this fantastic first opportunity you've had for video lesson learning. I just want to run through the points of kinetic molecular theory and how they are going to be important in what we're going to be studying. So first of all, the kinetic molecular theory really explains how substances react with each other during physical changes. We are not chemically changing anything in this unit. We are going to be undergoing, or not, I shouldn't say this whole unit, but for our beginning discussions are going to be about phase changes. So those are physical changes. We're not chemically altering things, and that's why ECH is not going to change. But the ideas of kinetic molecular theory are the following. Kinetic molecular theory says that matter is made up of tiny particles that are in constant random motion. Okay, that's a basic part of kinetic molecular theory. The second part says particles are attracted or repelled to one another, and those attractions and repulsions we can talk about in terms of EI, and we will talk about them in terms of EI. So that interaction energy we talked about. So when you have attraction, it reduces the state of EI, and when you have repulsion, it increases the EI. Remember, we said closer particles have lower interaction energies, further apart particles have higher interaction energies. So obviously if there's attraction or repulsion going on, that is going to affect that. And then lastly, if you have particles that are warmer in temperature, they're moving faster than colder particles that are cooler in temperature. And that's because temperature really is a measure of the average kinetic energy. So if the temperature is higher, it has more kinetic energy. And that is stated right there, so you can jot it in your notes, because that's what temperature is. Temperature is a measurement of how fast particles are moving, how much kinetic energy those particles have, both in terms of their speed and their mass. So those are basic ideas of kinetic molecular theory. After listening to the video lesson, it's good practice to look over your notes, make sure everything makes sense. If there was any part that didn't make sense, just scroll back, go back to that one little piece and watch it again. Or if you want to watch it 2 times through, of course that would never hurt. It'll take twice as much time, but it will never hurt. So you've been given instructions on what to do now with the Socrative from either Mr. Stein or myself. So I hope you've enjoyed your first experience with video lessons. I promise that they are more exciting most of the time than this one. This one's just a simple PowerPoint to sort of get you going and make sure that you learn how to use the technology. Okay, I will talk with you guys later.